Welcome to an exciting journey through time and space. Today we're going to dive into one of the most fascinating topics in cosmology, the Big Bang. You've probably heard the term, but what exactly is the Big Bang, and how did it shape the universe we live in today? Let's start at the very beginning. The Big Bang theory explains the origin of the universe as we know it. It's the idea that the universe began as a singularity, an infinitely small, hot and dense point around 13.8 billion years ago. From this tiny point, the universe began to expand rapidly, and this expansion continues today. Imagine everything we see in the universe, stars, galaxies, planets, came from this tiny, extremely dense point. This event was not an explosion in space, but rather an expansion of space itself. As the universe expanded, it cooled down, allowing matter to form. But let's rewind even further. Before the Big Bang, there was nothing we can really describe. No space, no time, no matter. Just a singularity, infinitely dense and hot. The Big Bang isn't an explosion in space, but the beginning of space itself. In the first few moments after the Big Bang, the universe was incredibly hot, hotter than anything we can imagine. In fact, it was so hot that atoms couldn't even form. Instead, we had a soup of particles, quarks, electrons, and photons. As the universe expanded and cooled, quarks began to combine and form protons and neutrons. These particles eventually formed the nuclei of atoms, mainly hydrogen and helium. This stage is known as cosmic nucleosynthesis, the formation of the first elements in the universe. But it didn't stop there. Around 380,000 years after the Big Bang, the universe cooled enough for atoms to form. This moment is called recombination, and it allowed light to travel freely through space for the first time. This light, still detectable today, is known as the cosmic microwave background radiation, CMB. The CMB is like a snapshot of the early universe, frozen in time, and it provides us with valuable clues about the universe's beginnings. As the universe continued to expand, matter started to clump together under the force of gravity. These clumps eventually formed the first stars and galaxies. The first stars lit up the universe in what's known as the cosmic dawn. These stars were much larger and shorter-lived than the stars we see today. Through nuclear fusion, these early stars began creating heavier elements like carbon, oxygen, and iron. The death of these stars, through supernova explosions, spread these elements across space. This process enriched the universe with the building blocks for planets, life, and everything we know today. Fast forward billions of years, and the universe has continued to expand. In fact, scientists have discovered that this expansion is actually speeding up. This discovery has led to the idea of dark energy, a mysterious force that is causing the accelerated expansion of the universe. But how do we know all of this? Scientists have gathered evidence from a variety of sources. 1. Observations of the cosmic microwave background radiation. 2. Measurements of the redshift of galaxies, which shows how galaxies are moving away from us. 3. The discovery of dark energy and its influence on the universe's expansion. All of this evidence supports the Big Bang theory and paints a picture of a universe that started small and has been expanding ever since. But the Big Bang theory is not the only theory about the universe's origin. Other ideas, like the steady-state theory, suggest that the universe has always existed in a constant state. However, the Big Bang theory is the most widely accepted because it best explains the evidence we see in the universe today. So, what happens to the universe in the future? Well, scientists are still trying to figure that out. There are several possibilities. 1. The universe could continue expanding forever, getting colder and more distant. 2. It could eventually slow down, stop, and then collapse in a big crunch. 3. Or it could expand forever at an accelerating rate, leading to a scenario called the Big Rip, where galaxies, stars, and even atoms are torn apart. What we do know is that the universe is still expanding, and that expansion has been going on for billions of years. This expansion is one of the most important pieces of evidence for the Big Bang theory. Another key aspect of the Big Bang theory is the idea that the universe is homogeneous, meaning it looks the same no matter where you look on a large scale. This uniformity suggests that the universe started from a single point and expanded outward in all directions. It also means that we are all connected to the same beginning, from the stars in the sky to the earth beneath our feet. It's truly amazing to think that we are made of the same elements that were created in the very first moments of the universe's existence. This realization brings a sense of awe and wonder as we look up at the stars. The Big Bang not only explains the origin of the universe, but it also helps us understand the fundamental forces of nature. Gravity, electromagnetism, the strong and weak nuclear forces, all of these came into play as the universe expanded and evolved. The study of the Big Bang also raises deep philosophical questions. For example, if the universe began with the Big Bang, what happened before it? Was there a before, or was time itself created in the Big Bang? These are questions that scientists and philosophers continue to ponder. While the Big Bang theory gives us a strong understanding of how the universe began, it doesn't explain everything. For example, it doesn't tell us why the Big Bang happened in the first place, but that doesn't make the Big Bang theory any less fascinating. In fact, it's one of the most important discoveries in modern science, reshaping our understanding of the cosmos. As we continue to explore space and look deeper into the universe with telescopes and advanced technology, we'll likely learn even more. Who knows what the future holds? The Big Bang is just the beginning of our quest to understand the universe. So, the next time you look up at the night sky, remember, you're looking at the remnants of the Big Bang itself. Everything we see, everything we know came from that one moment in time, 13.8 billion years ago. The universe is vast, mysterious, and constantly evolving. And the Big Bang was just the first chapter in an incredible cosmic story. Thanks for joining us on this journey through time. We hope this video has inspired you to keep asking questions about the universe. Feel free to like, share, and subscribe for more deep dives into the wonders of science and space. Until next time, keep exploring and keep wondering.